Welcome. This is the last part of the lesson on construction scheduling. So we'll cover activity flows. So in the last three videos, we have covered the process of developing schedules. We've learned about how to construct a network for your schedule. We learn about the CPM calculations, the forward pass and the backward pass, to figure out the early times and the late times of your activities. So you know exactly with this activity, the earliest I can start and finish it, and when will be the latest I can afford to start and finish it. So we can build on that now on learning some important concept here. So now I have early times and late times of activities. So if early time is equal to late time in any activity, this means that this activity has no flexibility. I'm stuck. I cannot start earlier because sequencing and logic, I depend on other things before it. So this is the earliest. But also I cannot afford to wait and delay it for beyond that point. So I call it a critical activity. It's critical because it is any delay will push the finish of the whole project. If there is another case, which is that the late time is more than the early time. So in that case, I can start earlier. The earliest I can start activity is this day, but then I can wait until a couple of days, 2 days, 3 days, until I will be more worried or very critical about it. So this activity we call it's flexible activity, and another word for it is non-critical activity. Of course, here we're not showing the other possible scenario, which is that the early time is more than the late time, because this is not feasible. Early time should always be less than the latest time or equal to it, if it's a critical case. So now we need to look at our activities, not only knowing the early and late times, but also summarizing this information by saying if it is critical or not. And if it's not critical, how much flexibility I have with it. So when I now look at these critical activities, I need to understand why they became critical from the first place. So these critical activities are what we call on the critical path, or also called the longest path. So it's the longest chain of activities that collectively their durations, when you add them, this is the longest chain of work compared to other chains or other series of activities. So it's the longest path or the critical path that control the project duration and made them all critical. So critical path is the longest path. If you think about the network, it has multiple paths. The longest path is the critical path, and it's the one that controls the project duration. A network might have actually more than one critical path. So if you're aggressive and doing your work in parallel, so you might make your whole project critical, because everything will be done within 7 weeks. Every day I will have a parallel work to do. So if you're so aggressive like that, you can make your whole project critical. So all the paths in the project will be critical. All the paths in the project will have the same duration, the longest duration. So how to measure the criticality of activity? It's by floats. Some books or some references call it slacks. Floats, slacks, they're the same thing. It's just the amount of flexibility you have in executing these activities. If you cannot change the execution time from the earliest time, then basically it's critical. If it's not the case, then it's non-critical. We have multiple types of floats. So in this class here, we're covering only two: total float and free float. There are other funny floats called, another float called independent float. There's actually another float called phantom float. Phantom. Seems scary, but it's not. But it's a float that's created due to complications with managing resources. So if you Google it, you will find that there's an article on the ASCE Journal of Construction Engineering and Management by Professor Chema de la Garza. And so it's a very interesting concept, phantom float. So, but for now we'll learn the basics, total float and free float. So we'll start with the total float. So total float is the amount of flexibility an activity can be delayed or can be executed with without affecting the project completion date. So from this definition, it's just the difference between the late times and the early times. So if I look at my schedule here that I used to explain the CPM concept, C here has 3 days float. It's either equal to 8 minus 5, so late finish minus late start minus early start, or 10 minus 7, so late finish minus early finish. Either or, in a typical case, in a simple schedule, this will be the total float. We'll see in the next lesson, in some cases when you start overlapping activities and using complicated logic, this equation here for the total float will not hold true. So we'll see that when we become more proficient and we'll learn more about special cases of schedules. So that's total float. It's just your limit of delay here is the whole project. You're actually worried about this point, okay, the end of the project. Free float, you're more conservative. You're actually limiting your flexibility of executing activities, so you're worried about the following activities, not the end of the project, but the succeeding activities. So you're worried about not affecting the early execution time of any of the succeeding activities. So you're more restricted, right? You're not relaxed and say, oh, the project finishes so far from now. No, you're actually really worried about those coming after you. So free float is equal to the smallest early start of the succeeding activities minus the early finish of this activity. All right, so this is the flexibility I have. I'm limiting myself more than the total float. So to explain this concept, let's now revisit this example we have seen before. So we had A, B, C, D, but now instead of having C, only one C, I have C1 and C2. So both of these have like 2 days durations. If I look here, of course, A, B, and D are all critical activities. There's the one thing also you have to note is that if total float is equal to 0, free float will be equal to 0 right away. Because total float, you're worried about a point in the future, far in the future, so you're more relaxed. If you want to think about more restrictive free float, now you're more restrictive than if you're more in the relaxed case, you're 0 float, then of course in the restrictive case you will have 0 also. So as a rule, if you end up with a free float more than the total float in in one activity, there is something wrong. So you have always to check at this case. But automatically, if you have a total float equal to 0 for an activity, the free float will be equal to 0. Now, this makes us focus on the non-critical activities. So both C1 and C2, they have 1 day float, total float, right? I can push C 1 day, which means it will push C2 1 day, but I'm still not that worried. I'm not delaying D. So that's from the total float perspective. But from the free float perspective, if I push C2 1 day, I'm not pushing D, right? So it has a free float of 1 day. We covered that. So C1 and C2, they both have a total float of 1. They actually share the same total float of 1. But if I think about free float, C2 has 1 day free float, but C1 has 0 free float. Because if I delay C1, I'm not concerned about the 15-day limit here. I'm actually concerned about this point. I'm concerned about very courteous about C2, that I don't want to delay C2 beyond its early time. So generous, right? So for C1, I will limit myself to this point. So this means I have 0 free float. So what's the use of that? So total float is more relaxed, free float is more restrictive. So general contractors would kind of use the free float language to tell the subcontractors who are doing early work in the project that you are not that relaxed. You're actually affecting the subcontractors coming after you. Because if I am subcontractor 1 and there's a second subcontractor 2 coming after me, if I relax and keep delaying my work, I'm actually eating up of the float of the subsequent or succeeding contractors. So I'm then making them more tense, and I'll be done with my work, leave the project, get my pay, and that's it. So now general contractors will speak the free float language with the early subcontractors early in the project to urge them to finish following their early times, not the late times. So that's the reason for learning about the free float. It's kind of relates to how the project is executed, how the general contractor, as the leading contractor in a project, coordinates between the subs. So this is the same example we've seen in the previous lecture. We kind of drew already the schedule for it, calculated the early and forward pass and late pass calculations for early and late times, and we figured out the duration. Now we need to figure out the critical path or paths and calculate the floats for the activities. So if I look at the early and late times, any early and late time that are equal, this is automatically right away, it's a critical activity. So 0055, this is a critical activity. 610, 610, so I can now mark my critical activities, and you can see also they're forming a critical path. So if I'm doing that, and I saw that A and C are critical and G are critical, but E is not, then there's something wrong. I have to check my calculations with E. So always, like, CPM is really a nice method because it gives you checks. It gives you these handy checks that you can make sure that you validate your answer and make sure you end up with the correct answer. So these are critical activities. My critical path is A, C, E, G. Now what about the other activities? They have floats, right? So I can calculate the total floats, and they're basically the difference between the red and the blue numbers. So 3 minus 0 or 6 minus 3, this is total float of 3 days for B. D and F, these are the total floats for them, 12 minus 10 or 14 minus 12, 2 days for D, and similar thing for F. One thing here to note is that F seems to have more float than D, but don't be tricked because already 2 days of the total float for F is shared with D. How to understand that? Let's imagine this D is delayed 2 days. F doesn't have any more 4 days float. It actually consumed already 2 days of it because D was delayed. And this is again idea of if you are a subcontractor down the stream and the schedule of the project, you will be so worried about the subcontractors before you, and you'll always be complaining, they're finishing later than should be and they're squeezing me. So that's because they are eating up of my own float here. Remember, a float here is shared within the path, or what we call the chain of activities. So this is a non-critical chain. And this non-critical chain has a 4 float that is shared between the activities. This D activity can only share 2 of it because of the limits of the G activity, which is a critical activity here. It's another chain that's overlapping with this non-critical chain of activities at D. So give it more thought into the numbers, and you actually get more insights after CPM calculation. You get more insights how the dynamics here. What will happen if I delay an activity, a non-critical activity? It actually have more impact than you can think of initially. Free floats now, everything that has 0 total float is 0 free float. So right away you start writing zeros for free float for the critical activities. Now for others, you have to calculate it. So for B, it has a 3-day free float. How is that? It's equal to the early start of the succeeding activities. So I have only number here 6 minus the early finish of the B. So it's 6 minus 3, 3. Let's check D. So D here, the earliest early start of the succeeding activities. So I have here 12 and 14. The earliest is 12. So 12 minus the early finish of D, 12 minus 12 is 0. And that's really eye-opening here. So total float, if I think in the relaxed way, D has a total float of 2 days. But in the more restrictive way, if I want to more encourage that sub working on activity D, that to be curious with the activity F subcontractor, I'll tell them you don't have any flexibility, finish on time, you have to finish, start on 10 and finish by 12. So it has a 0 free float. F has a free float of 4. Why is that? Because if you think about it, it's the finishing activity. So the finishing activity, the early time that you're comparing yourself to is the finish time of the whole project. So 19 minus 15, that will be a free float of 4. So kind of a rule by practice. If you have a finishing activity, here F and G are finishing activities, their total float will be equal to free float. So if my total float is 4, kind of I expect the free float to be also equal to 4. All right. So these are some notes here. If you have a D is at the beginning of a non-critical activity, so D is here. So at the beginning of a non-critical chain, then it's, in this case here, its free float is equal to 0 because you don't want to push anything beyond it. But F here is at the end of the non-critical chain, so now it enjoys that free float that's reserved for its execution. So that's the end of the scheduling, the series on construction and scheduling. Really, activity floats is just the summary of everything you did in scheduling. You can look at the floats and understand now the kind of the executive summary of the project schedule. You can see what are the critical activities, what are the non-critical activities. For non-critical activities, how much flexibility I have for each one. All right, thanks for watching. Take care of yourself and those around you.